Hello guys, welcome to Security Red versus Blue Team channel. In today's video, we'll discuss on OWASP top 10 list. So let's get started into the topics. So OWASP top 10. So what is OWASP? And in the top 10 list, what is the broken access control? What is cryptographic failures, injection, insecure design, security misconfiguration, vulnerable and outdated components, identification and authentication failures, software and data integrity failures, security logging and monitoring failures, server-side request forgery. So we'll be covering all these top 10 lists from the OWASP community. So let's get started into the topic. So, what is OWASP? So, OWASP is an open web application security project. It's a non-profit organization founded in 2001. The main goal of this OWASP is to helping the website owners and the security experts protect their web applications from the cyber attacks. The OWASP has some 32,000 plus volunteers around the world who perform the security assessments and the research. So, this OWASP online community produces freely available articles, methodologies, documentation, tools, and technologies in the field of web application security. The WASP provides a free and open source resources. It is led by a non-profit organization called WASP Foundation. This list is updated every few years based on the combination of security testing, data, and surveys of professionals within the industry. So the most recent version of the WASP Top 10 list was released in 2021. So we'll be discussing the top 10 list which was released in the 2021. After that, we don't see any. The new list has been released. So let's cover this top 10 list. So, and before going to the topics, this WOWAS top 10 has many categories when it comes to mobile security. It has separate top 10 list. When it comes to threat intelligence, it has separate list. This is mainly for the web application. And when it comes to API security, we have separate WOWAS top 10 list. So we'll be covering only the web application purely for the web. Um, so let's get started. So broken access control. So this is the top one in the list. So broken access control is like in case if the attacker is able to gain the access to the system. So how can we limit the data that is being exposed to the user? So that we'll be discussing in the broken access control. So if you look at the definition, access control enforces the policies such as the users cannot act outside of their intended permissions. The failures typically lead to unauthorized information disclosure, modification, or destruction of all the data, or performing a business function outside the user's limit. The common access control vulnerabilities include bypassing the access control checks by modifying the URL, permitting the viewing or editing the someone else's account, accessing the API with missing access control to post, put, and delete methods, and violation of principle of least privilege and deny by default, and privilege escalation and data manipulation. CORS misconfiguration allows APIs from unauthorized or untrusted origins, forcing the browsing forcing force browsing to unauthenticated pages as an unauthenticated user, or to privileged pages as a standard user. So these are the common vulnerabilities when it comes to broken access control. So if you look at the prevention methods, we need to implement access control permissions, even if we get access to some sort of information, and rate limiting the API and controller access to minimize the harm from unauthenticated automated attacking tool, and except for public resources, deny by default. Disable the web server directory listing. This is one of the common attacks that we see even today. And log access control failures and alert on admins when needed, and implement access control permissions. So these are so when it comes to broken access control, so these are the vulnerabilities and prevention techniques that one must follow when designing an application. And second one is the cryptographic failures. So this is like basically using the weak cryptography. So the first thing is to determine the protection needs for the data in transmit and data in rest. For example, the passwords, credit card numbers, healthcare records, and personal information and the business secrets require extra protection, mainly if that data falls under privacy laws. Example, GDPR, PCI DSS. So the mainly these are the things to be taken care for the data security. Ensure the data is not in the clear text format. Either it should be in yeah, encrypted format. It can be any hash algorithm. Either it can be MD5 or any other SHA algorithm. And no old or weak cryptographic algorithms or protocols to be used. And ensure to have a proper key management. Ensure is the proper pre-certificate validation is done, and are the decrypted hash functions such as the MD5 and SHA1 is used. The decrypted cryptographic padding methods such as the PKCS is still in use. or the cryptography error message or side channel information is exploitable. So these are the things we need to mainly take care when it comes to cryptography failures. So how can we overcome? So if you look at the preventing techniques, so first we need to classify the data, then process the data accordingly, and mainly to classify what need to be processed, what need to be stored, and what needs to be transmitted by an application. Identify which data is sensitive according to the privacy laws and regulatory requirements or the business records. So based on that, act accordingly. And don't store the sensitive information unnecessarily. Discard the data as soon as possible. Or the PCI DSS complaint tokenization or even truncation. So don't use the legacy protocols such as FTP or SMTP, and disable the web server directory listing, and make sure to encrypt all sensitive data at rest. Ensure up-to-date and strong standard algorithms and protocols and keys are in place, and use proper key management, and always use authenticated encryption instead of just encryption, and verify independently the effectiveness of configuration and the settings. So these are the prevention techniques one must take care when it comes to cryptography. And the third one is injection. So here it can be any sort of injection. It can be like PHP or HTML injection. It can be SQL injection, or it can be a command line injection. So some of the more common injection techniques are like SQL, NoSQL, OS command, and object related mapping, an LDAP or expression language, or an object graph navigation library injection. So the concept is identical among all the interpreters. The source code review is the best method for detecting if applications are vulnerable to injections. So if you look at the common vulnerables stuff when it comes to injection, the user supplied data is not valid or filtered or sanitized by the application. The dynamic queries or the non parameterized calls without context aware escaping are used directly in the interpreter. Hostile data is used within the object relational mapping search parameters to extract additional and sensitive records, and hostile data is directly used concatenated. The SQL or the command contains the structure, the malicious data in dynamic queries, commands, and are stored procedures. So these are the vulnerable to application. And if you look at the preventing techniques, we need to use a positive server-side input validation for any because mainly in the injection attacks, the input validation is lagging. This is what the main thing which is causing the injection attacks. And use a limit and other SQL controls within the queries to prevent the mass disclosures of records in case of SQL injection. For any residual dynamic queries, escape special characters using the specific escape syntax for that interpreter. And also the preferred option is to use the safe API and limit the errors that is being disclosed whenever the failure is displayed when attacker tries to inject with some malicious input. So these are the preventive techniques one must take care when it comes to injection. And the fourth one comes the insecure design. So insecure design is a broad category representing the different weaknesses expressed as missing or ineffective control design. A secure design can still have implementation defects leading to vulnerabilities that may be exploited. It could be zero-day exploit as well, which is very hard to find out. An insecure design cannot be fixed by a perfect implementation as by definition, but it needed a security controls were never created to defend against the specific attacks. So one of the factors that contribute to insecure design is the lack of business risk profiling inherent in the software or the system being developed, and thus the failure to determine what level of insecurity design is required. So how one must prevent the insecure design? So establish and use a library of secure design patterns or ready to use components, and establish and use a secure development lifecycle with the AppSec professionals to help evaluate and design security and privacy related controls. And one must limit the resources consumption by user or the service, and segregate the tenants robustly by design throughout all tiers, and also use threat modeling for critical authentication, access control, and business logic and key flows. And this is the one of the main thing. And I think we'll come up with a topic on how to do a threat modeling by using it can be a Badra framework or it can be a Microsoft Stride model, and we have other models too. We'll shortly come up with a video on how to do a threat modeling. The next comes the security misconfiguration. So this is one of the most important vulnerabilities which is instance today. The security misconfiguration occurs when system or application configuration settings are missing or are erroneously implemented. Allowing an unauthorized access, common security misconfigurations can occur as a result of leaving default settings unchanged. Erroneous misconfigurations change are the technical issue. So these we will be seeing during the installation. Some default security configurations will not been touched, so we need to mandatorily change the default settings of a system. It can be a default username or password. And also another area is like whenever the system is migrated from the old system to new system, some of the configurations will be still be in place without being properly checked. So application is vulnerable to attack when these things are not followed. So when the default accounts and their passwords are still being still enabled and unchanged, and unnecessary features are enabled and installed, and missing the appropriate security hardening across any part of the application stack, or improperly configured permissions on the cloud services. And then the error handling reveals the stack traces or other overlay information error messages to users. And for upgraded systems, the latest security features are disabled or not configured securely. The software is out of date or vulnerable. So these are the more important things that can cause an attack when it comes to security misconfiguration. So how do we prevent it? So like if you look at the prevention techniques, a repeatable hardening process make sure makes it fast and easy to deploy another environment that is appropriately locked down, and minimal platform without any unnecessary features, components, or documents, data and samples. Remove or do not install unused features and frameworks, and sending the security directives to clients. Example, security headers, an automated process to verify the effectiveness of the configurations and settings in all environments. The task to review and update the configurations appropriately to all security notes, updates, and patches as part of the patch management process. A segmented application architecture provides the effectiveness and secure separation between the components or tenants with segmentation, containerization, or cloud security groups. So these are the important things one must take care when it comes to security misconfiguration. Next comes the vulnerable and outdated components. A vulnerable and outdated component is a software component that is no longer being supported by the developer, making it susceptible to security vulnerabilities. Many times, a component has known vulnerability that doesn't get fixed due to lack of maintainer. So the application is vulnerable when if the component configuration is not secure, if we do not fix or upgrade the underlying platform frameworks and dependencies in a risk-based and timely fashion, if you do not scan for vulnerabilities regularly and subscribe to security bulletins related to the components you use. If the software is vulnerable, unsupported, or out of date, if you do not know the versions of all components you use, both client side and server side, this includes components you directly use as well as the nested in the documents. So these are the things when the application is application will lead to application vulnerable. And if you look at the prevention techniques, so we need to remove the unused dependencies, unnecessary features, components, files, and the documents which is present in the application, and continuously do the inventory of the versions that is being installed for the applications. It can be any applications on both client or server side, and obtain components from the official resources, only the secured links and preferred signed packages to reduce the chances of including a modified and malicious component, and monitor for libraries components. And I think that this previous point has to be mainly taken care when you are downloading the third packet packages. Mainly ensure that it is being downloaded from the secure links. And last one is monitor for libraries and components that are unmaintained or do not create security patches for older versions. So these are the prevention techniques one must take care for vulnerable and outdated components. The next comes the identification and authentication failures. Identification and authentication failures occurs when the application fails to correctly implement functions associated to the user's identity, and the session management and confirmation of the user's identity. Authentication and the session management is critical when it comes to protecting against authentication based attacks. So there may be a authentication weakness if the application permits a brute force or other or authenticated attacks, and uses a plain text encrypted or weakly hashed passwords and data stores, and application is vulnerable when it has a missing or if a ineffective multi-factor authentication, or when that does not correctly invalidate session IDs and exposes session identifier in the URL, or permits automated attacks such as credential stuffing, where the attacker has to list a valid username and passwords, and permits the default weak or well-known passwords such as password one or admin or root at 123. So these are the things which can cause application to be vulnerable. So we look at the prevention techniques. Wherever is possible, implement a multi-factor authentication to prevent the automated credential stuffing, brute force, and stolen credentials or reuse attacks. And do not ship any or deploy by any with any default credentials, particularly for admin users. I think this is still we have seen in most of the companies where the default credentials are shipped by default. And implement a weak password checks as a testing new or changed passwords against the top 10,000 worst password list. I think this one must take care, which is mostly the best technique to be used. And limit or increasingly delay the failed login attempts, but be careful not to create a denial of service scenario. I think this most of the place it's already implemented, and use a server side secure and built-in session manager that generates a new random session ID. So these are the top important techniques one must take care when it comes to identification and authentication failures. And the next comes the software and data integrity failures. So it is essential to make sure that all the data is encrypted before sharing. All the data must go through the extensive integrity check and should be backed up by a digital signature. This method will help the user to gain access to the valid data and protect the system from attackers, software, and the data integrity failures related to code and infrastructure that does not protect against integrity violations. As an example of this, this is where an application relies upon plugins, libraries, or models from the untrusted sources, repositories, and the content delivery networks, which is the CDNs. The insecure CI/CD pipeline can introduce the potential for unauthorized access, malicious code, and system compromise. So this is when it comes to software and data integrity checks. So if you look at the prevention methods, use digital signatures to verify the software and ensure the libraries and the dependencies such as like npm are consuming the trusted repositories, and ensure that there is a review process for the code and the configuration changes to minimize the chance that the malicious code or the configuration could be introduced to your software pipeline. I think this is one of the thing which is mainly missing at most of the places after any upgrade or any code change. And ensure that your CI/CD pipeline has a proper segregation, configuration, and access control to ensure that the integrity of the code flowing through the build and deploy process, and ensure that unsigned or unencrypted serialized data is not sent to untrusted client without some form of integrity check or the digital signature to detect even tampering or relay of serialized data. I think this is one of the important steps that has to be taken care. There should be a sign. It should be signed and serialized form. So these are the top prevention methods one must follow when it comes to integrity checks. And the ninth one, security logging and monitoring. So I think this is one of the OWASP top 10 list which is present since many years. And security logging and monitoring is intended to be an early indicator of threat attacks and data breaches. So without proper systems in place, your business can be at risk of the following: login or failed attempts not being logged, and all attempts should be recorded. Without logging and monitoring, breaches cannot be detected. Insufficient logging, detection, monitoring, and active responses can occur anytime. Um, so mainly warnings and errors generated inaccurate in unclear log messages, and logs are only stored locally, and logs are logs of applications, and mm, APIs are not monitored for suspicious activity. Penetration testing and scans by dynamic application security testing tools do not trigger alerts. And appropriate alerting thresholds and response escalation process are not in place or effective. The application cannot detect, escalate, or alert for effective attacks in real time or near real time. Um, Auditable events such as logins, failed attempts, and high value. transactions are not locked. So if you look at the prevention methods, the developer should implement some or all of the following controls depending on the risk of the application. So you need to ensure that logs are generated in the format that the log management solutions can be easily consume the data that is being logged. Ensure log data is encoded correctly to prevent the injections or the attacks on the logging or monitoring system. Ensure high value transactions have an audit trail with integrity controls to prevent tampering or deletion, such as append only database tables or similar. The dev security operations team should establish effective monitoring and alerting such that the suspicious activities are detected and are responded to quickly to quickly establish or adopt an incident response and recovery plan, such as National Institute of Standards and Technology. Ensure all login success controls and server-side input validation failures can be logged with sufficient user context to identify suspicious or malicious accounts held for enough time to allow delayed forensic analysis. These are the major steps that needs to be followed when it comes to security logging and monitoring, so that any false attempts are not missed. Next comes the server-side request forgery, which is the last in the OWASP top 10 list. Though SSRF, it's also got a server-side request forgery. Uh, Flaws occurs whenever a web application is fetching a remote resource without validating the user supplied URL, and it allows an attacker to concentrate the web application to send the crafted request to an unexpected destination, even when the protected by a firewall VPN or another type of network access control list. As modern web application proves end users with the convenient features where fetching a URL becomes a common scenario. As a result, the incident of SSRF is increasing. Also, the server severity of server-side request forgery is becoming higher due to the cloud services and the complexity of mobile architecture. And if you look at the prevention methods, the developers can prevent the SSRF by implementing some or all of the following defense in-depth controls. So mainly sanitize and validate all the client-supported input data and segment the remote resource access functionality in separate networks to reduce the impact of SSRF. And also enforcing the deny by default firewall policies or the network access control rules to block all the essential internet traffic, and do not send the raw responses to clients and disable all the HTTP redirections, and be aware that the URL consistency to avoid attacks such as DNS rebinding and time of check and time of use race conditions, and do not deploy other security relevant services or on front systems. And for front ends with a dedicated and manageable user groups, use networks, encryption, and dependent systems to consider very high protection needs. I think these are the top methods that needs to be followed when it comes to prevention of server-side request forgery. I think that's it, guys. We have completed OWASP top 10 list. So we mainly covered OWASP top 10, and when it comes to web, and what are the top 10 list which is present by the OWASP community. So the way we can check for OWASP API security, and what are the top 10 list for API security and other security as well, if you Google it. So yeah, so this is the topic which is the trending one we wanted to cover. So thank you guys. Thanks for watching. Please do like, share, comment, and subscribe.